Welcome back to my channel Math School. In today's video, let us solve example 17 from chapter 3, pair of linear equations in two variables. In my previous videos, I've completed the examples 1 to 6 and 11 to 13, exercises 3.1, 3.2 and 3.4. If you have not watched these videos, do find the link in the description box below or click the I button. Let us begin with the video. Section 3.5 from chapter 3, pair of linear equation in two variables is equations reducible to a pair of linear equations in two variables. So here in this section, we shall discuss the solution of such pairs of equations which are not linear but can be reduced to linear form by making some suitable substitution. So we have to reduce given pair of equations which are not linear to linear form by making some suitable substitution in the given equation. Now we shall explain this process through some examples. Example 17 says solve the pair of equations. So they have given us two pairs of equations and we have reduced them into a pair of linear equation, and then we have to solve them and find out their solutions. So as we all know, the standard form of a pair of linear equation is given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. But here you observe that the variable x and y is in the denominator, whereas it has to be in numerator in the standard form of linear equation. So now let us do some substitutions here to bring these two pair of equation into standard form of linear equations. Equation 1 given can also be written as 2 into 1 by x plus 3 into 1 by y equal to 13. Similarly, here in the second equation can be written as 5 into 1 by x minus 4 into 1 by y equal to minus 2. So here let us substitute 1 by x to any other variable like p, and let us substitute 1 by y equal to q. Okay, so we are substituting this variables 1 by x and 1 by y to some other variables such as p and q, and then these two equations will be reduced to standard form of linear equation. Let us write down, since the given equations are not in the form of ax plus by plus c equal to 0, so therefore we substitute p equal to 1 by x and q equal to 1 by y. Let us assume them to be equation 1 and 2. So let us substitute p is equal to 1 by x and q equal to 1 by y in equations 1 and 2. So therefore, substituting in equation 1 we get 2p plus 3q equal to 13. So let this be equation number 3. Similarly, substituting in equation 2, we will get 5p minus 4q equal to minus 2. So let this be equation number 4. So now here we can apply the elimination method, or we can solve them also graphically and find out the solution p and q. Now here let us solve by elimination method. So solving equations 3 and 4 by elimination method. Okay, so let us write down the equation. It is 2p plus 3q equal to 13 and 5p minus 4q equal to minus 2. So here you can see that the coefficients of these two equations p and q are different. Likewise, the coefficient of q are also different. They are not equal. So let us make them equal. Let us try to eliminate q variable here. So we have to multiply equation 3 with the coefficient of q from equation 4. So let us multiply with 4 here. Similarly, we have to multiply equation 4 with the coefficient of q from equation 3, right? So multiplying, we are going to obtain this equation here as 4 into 2 is 8p plus 4 into 3 is 12q equal to, what is 4 into 13? 4 into 3 is 12, carry 1, 4 into 1 is 4 plus 1 is 5, that is 52. Similarly, multiplying the second equation, 3 into 5 is 15p minus 4 into 3 is 12q equal to 3 into 2 is minus 6. So here we got the equation where the coefficient of q in both the equations are equal and also the sign is plus and minus. So here we can eliminate q variable. So we will be left with plus 8p and plus 15p. So we have to add with the plus sign. 8 plus 15, it will be 23p equal to, again here we have plus 52 and minus 6. So we have to subtract with a greater number sign. So 52 minus 6 will be 46, right? So we got 23p equal to 46, or p is equal to 46 divided by 23. So here we can cancel 23 one times, 23 two times. So therefore we got p as equal to 2. Now let us substitute this p value in equation 3 and find out the q value. So substitute p equal to 2 in equation 3. So from equation 3 we have 2p plus 3q equal to 13. So 2 into p is 2 plus 3q equal to 13. So 2 into 2 is 4 plus 3q equal to 13. Sending this 4 to right hand side, we get 3q is equal to 13 minus 4, that is equal to 9. So 3q equal to 9, or q equal to 9 by 3. 1 times 3 times is 9. So we got q value equal to 3, right? So we got p as 2 and q value as 3. But what we had assumed the p and q value as 1 by x and 1 by y. So here we have to find out the value of x and y. So since p is equal to 1 by x, so substitute the value of p is 2, that is equal to 1 by x. So let us send this x to left hand side and 2 to right hand side. So x comes in the numerator on left hand side and 2 will come in denominator on the right hand side. So x is equal to 1 by 2. Similarly, let us find out the y value. Q is equal to 1 by y. So q is also equal to 3. So we can write 3 is equal to 1 by y, or y is equal to 1 by 3. Okay, so we got x and y value, that is the solution for the given pair of linear equations. Therefore, we can write x is equal to 1 by 2 and y is equal to 1 by 3 is the solution for the given pair of equation. Right, so this is how we solve this problem. It is very easy. Whenever these kinds of problems are given, we have to substitute the variables 1 by x and 1 by y to another set of variables like p and q, and then we can find out the values of x and y. Okay, so this is how we solve this problem. If you have any further doubts, do comment me below in the comment section. In my next video, I'll be solving example 18 from chapter 3, pair of linear equations and 2 variables. So till then, do like my video, subscribe to my channel, and don't forget to hit the bell button below to get the latest updates of my videos, as I'll be completing the whole syllabus for class 10th SLC NCERT Math. And also do watch the related videos of chapter 3, pair of linear equations shown on the screen. Thank you.